Hey everyone, and welcome. I am absolutely thrilled to have you here for today's explainer because, well, today's date, August 27th, 2026, marks a massive tectonic shift in the world of technology. We're looking at a day completely packed with incredibly dynamic news across the entire artificial intelligence landscape. We are talking about next-generation agent architectures, shifting global financial markets, state-level sovereignty, and honestly, perhaps most importantly, the hard physical constraints of bringing AI into the real world. Now, before we get started, please make sure you hit that subscribe button for AI Vanguard, AI to stay right at the cutting edge of industrial AI. We've got a really inspiring visual story to walk through today, and if you find this synthesis valuable, please like, comment, and share. Okay, let's dive into this. For years, you and I have thought of artificial intelligence as something that lives exclusively inside our monitors, right? Kind of a disembodied brain that writes our emails, generates some cool images, or crunches our data. But what happens when that intelligence breaks out of the software sandbox and actually begins to operate in tangible reality? Today's developments show us exactly what that transition looks like. We are rapidly moving from a world where AI simply thinks to a world where AI acts, touches, and builds.
So to make sense of this massive shift, we're going to take a structured journey through today's news. We'll kick things off with next-gen AI models. Then we'll look at how AI enters the enterprise. From there, we'll check out real-world physical applications, followed by regulating the AI frontier, and we'll wrap up with powering the AI boom.
Let's start with Section 1, Next-Gen AI Models, the brains of the operation.
Now, what's really interesting about this slide is the clear contrast in the two approaches developers are taking to run complex, autonomous agents in 2026. On one hand, we have the lightweight speed approach. Z.AI has just officially deployed their GLM 5.3 Flash model. This thing is built specifically for high-throughput autonomous agent loops and low-latency coding. It's all about incredibly fast, continuous action. But then, on the other hand, we have open-weight power. The developer community is rapidly adopting models like Muse Glimmer 30B and Qwen 3.8-27B. And why is that? Because these models are now hitting crazy new benchmarks where they can run full 1 million token context windows natively on a single consumer GPU. I mean, you can run massive autonomous software testing entirely locally now.
And for those who don't want to just choose one model, because let's be real, bouncing between them is a hassle, the fragmentation problem is finally being solved. Today, a multi-model platform called SuperApp entered open access. This platform enables simultaneous workflows across Gemini 3.7 Flash, Claude Opus 5, Grok 4.6, and GPT 5.6, and it's all orchestrated within a single threaded enterprise workspace. So you can have one model generating a massive document while another handles your conversational queries, completely seamlessly. The crucial takeaway here is that the brains of AI are now faster, much more localized, and more unified than we've ever seen before.
Which brings us nicely to Section 2, AI enters the enterprise, or as I like to think of it, the hands.
Intel actually detailed a brilliant step-by-step instruction manual for corporate adoption today at the AI Infra Summit 2026. Step 1. They are deploying Gemini Enterprise directly on Google Cloud. Step 2. They aren't just using basic chat interfaces. They are actively integrating autonomous multi-agent workflows. And Step 3. They apply these agents directly to automate internal supply chain and engineering units. It's a very precise, measurable strategy to completely transform giant enterprise operations using modern AI infrastructure.
But it's not just back-office engineering. AI is fundamentally changing the devices in our pockets and how businesses actually reach us. Samsung just unveiled the Galaxy S26 FE, natively deploying One UI 9. This means the phone uses context-aware Galaxy AI for real-time visual search and even does adaptive battery routing based entirely on your generative usage. And because our devices are literally mediating our reality through AI, businesses are having to pivot hard. Frost & Sullivan, partnering with Optivara, just launched a new AI brand equity audit. Since consumers are asking LLMs for recommendations instead of scrolling through traditional search engines, brands now have to audit their visibility strictly inside autonomous AI pipelines if they want to survive. It's a whole new ballgame.
Let's move to and see how this builds into Section 3, Real-World Physical Applications. The actual physical real world.
Okay, I really want you to focus on this measurement, less than 1 millimeter. Clinical Robotics Consortium just published their new performance metrics for autonomous physical AI.
By using multimodal tactile perception arrays and microforce feedback systems, robotic arms used in surgical manipulation and biomolecular lab preparation are now achieving sub-millimeter precision. The AI can literally feel what it is doing in the physical world. It's manipulating delicate laboratory samples with a level of accuracy that absolutely redefines modern medical workflows.
And here is another measurement that is quite literally saving lives today. Under 90 seconds. Earth observation networks have activated real-time thermal vision models across low Earth orbit satellite constellations. This AI isn't just up there taking pretty pictures, it is actively monitoring for climate events. The automated system can detect a wildfire from orbit, route the containment data, and trigger an emergency dispatch in under 90 seconds. Just think about that. From space to the firehouse in a minute and a half.
This brings us to Section 4, regulating the AI frontier, establishing the guardrails.
So as things scale, regulators are stepping in. The European Commission AI Office has officially activated cross-border enforcement of the EU AI Act, specifically Articles 50 and 101. A key pillar of this is defining and enforcing machine-readable cryptographic watermarking. I know, it sounds like a lot of jargon, but basically, this is a mandatory hidden digital signature required to clearly identify AI-generated content. If general-purpose AI providers fail to implement this, or if they fail to provide explicit chatbot disclosure rules, they are going to face immediate, heavy financial penalties. Regulators are essentially ensuring that as AI scales, its outputs remain fully traceable.
Meanwhile, over in the US and through various global security bodies, the focus is really on containing the physical actions of AI. They have issued new multi-agent sandbox directives, instructing enterprise engineering teams to implement very specific boundaries. First, hardened virtual machine isolation. Second, enforced least privilege API boundaries, which basically means the AI only gets access to the exact tools it needs for a specific task and absolutely nothing more. And third, automated circuit breakers to prevent any unauthorized autonomous tool execution. It is an entirely neutral, purely engineering-driven approach by governments to ensure these multi-agent systems do not execute commands beyond their intended scope.
Finally, we arrive at Section 5, powering the AI boom, looking at the hardware and infrastructure.
To actually comply with the regulations we just discussed, regional data center operators in Europe have deployed dedicated sovereign European GPU cloud infrastructure. These are zero data egress clusters. That simply means the data never leaves the regulated zone, providing a completely sovereign compute foundation specifically for public sector and enterprise AI workloads. But, as you might guess, running these massive sovereign clouds requires just staggering amounts of power and cooling.
And this brilliantly illustrates exactly how hyperscalers are physically rewiring the power grid across North America and Europe in a step-by-step infrastructure upgrade. First up, to manage the extreme thermal output of these massive AI chips, facilities are literally ripping out traditional air conditioning and installing high-density liquid-cooled hardware. Second, because waiting to connect to the public power grid can cause multi-month delays, utilities are utilizing behind-the-meter battery storage to bypass that wait time entirely. And third, they're building on-site modular substations to independently power these new megawatt AI facilities. They are quite literally having to build their own microgrids just to keep the AI brains turned on. Which leaves us with this massive lingering question. As AI bridges the gap from limitless software to constrained physical reality, will our power grids and infrastructure become the ultimate bottleneck to innovation? We have the brains, we have the enterprise workflows, and we clearly have the robotics. But if we can't power the data centers, the physical expansion of AI might hit a brick wall. It's a fascinating constraint to a seemingly limitless technology. Well, thank you so much for joining me for today's Explainer. Again, if you found this synthesis valuable and enjoyed the step-by-step breakdown of today's tech, please like, comment, and share this with your network. And don't forget to subscribe to AI Vanguard AI to stay at the cutting edge of industrial AI. I can't wait to see what you all think about the physical future of AI. See you next time.